A set of data items is normally distributed with a mean of 100 and a standard deviation of 20. Find the data item in the distribution that corresponds to the given z-score. So our z-score is 1.5. Remember what the formula is. So we know when we're looking for a z-score, that's equal to the data item minus the mean divided by the standard deviation. So we can use this formula, except for this time we are going to be looking for the data item. And we know already what the z-score will be, we know what the mean is, and we know the standard deviation. So we're going to substitute those in, and then you're going to solve it like you would in an algebraic equation. Okay, so my z-score is going to be 1.5, and that's equal to the data item, which I don't know, minus the mean. Remember, the mean is 100. And then all over the standard deviation, which we're told is 20. Okay, and like I said, this is just a algebraic equation you want to solve. Since I have a fraction in here, I can go ahead and cross multiply, or multiply both sides by 20 to get rid of the fraction. So 20 times 1.5, I get 30 is equal to, and then over here they cancel, so I'm left with x minus 100. And now I'm going to go ahead and bring the 100 over, or by adding 100 to both sides. And so we end up with x is equal to 130. So the data item that we're looking for is 130. Okay. All right, the next one here. All right. A random sample of 2,311 college students were asked their major. The top 5 responses and the percentages of students who named each of the top 5 majors is shown in the graph. Use the graph to answer the questions. So first we're asked to find the margin of error to the nearest tenth of a percent. Okay, so ask yourself, what is the formula for finding, the margin of error? So it's plus or minus 1 over the square root of n, where n is the size of the sample. So in this case here, n is equal to 2,311. So 1 over the square root of 2,311. I'll plug this into my calculator and I get 0.0208, a bunch of stuff. We're supposed to round it off to the nearest tenth of a percent. So I will go ahead and change this to percent. So I get, moving it over to, like multiplying it by 100. So 2.08%. or 2.1% rounded to the nearest tenth. So that's my answer for the first part. Okay. The second part, they asked me to write a statement about the percentage of students whose major is pre-law. Okay, so remember what we mean by the a margin of error is 95% are gonna lie within that margin of error. So if you go look over here at pre-law, that's 10% of the students. So really what I'm looking for is 10% plus and minus 2.1%. So I need to do 10% plus 2.1%. So I get, 12.1%. And I also need my 10% minus my 2.1%, which will give me 7.9%. So that means that 95% of the responses lie between 7.9% and 12.1%. Find the mean for the data items in the given frequency distribution. I'm going to go ahead actually and find the mean, median, and mode for this one because it's a little bit different when we have a table with a frequency distribution as opposed to just listing out the data items. Okay, so first let me go ahead and do the mode. Remember that mode is the, most frequent. So if I look at the frequencies, remember this is the data items. This tells me like the data item is a 1 and it occurs once. The data item 2 occurs 3 times, and so forth. So I look at which ones occur the most. So down here I say that 6 is the highest frequency. So I actually have 2 modes. This one's going to be bimodal. So my modes are going to be 4 and 7 because these are the data items. So I actually have to, the mode is going to be the data item itself. Next, let me go ahead and find the mean. The mean, remember, is the sum of all the data items divided by the total number of data items. So because it's given to us in this manner here, in this frequency distribution, right, I've got to make sure, this is the same thing as a weighted graph. So I have to go ahead and make sure that I'm counting all of them. So again, I'm going to go ahead and say, well, I've got 1, 1. So I've got 1, 1. And then I have 3 2s. So I have 3 2s. I have 2 3s. There are 6 4s. There are 3 5s. 2 6s. 6 7s. And then there's 1 8. So that's going to be all of my data items. I have to add all those up. And then how many data items are there? Don't forget that, there's not just 8 of them. I got to count them with, all the frequencies, because there's, like I said, you got to think about there's 1 1, and then there's a bunch of 3, a couple 2s, some 3s, some 4s. They're not just one of each. So I've got to add them all up. So 1 plus 3 plus 2 plus 6 plus 3 plus 2 plus 6 plus 1. So I'm adding up all the frequencies, and that's going to give me my total number of items. All right, so plugging this into my calculator in the numerator, let's see, I get 1 plus 6 plus 6 plus 24 plus 15 plus 12 plus 42 plus 8. All right, and then the bottom, let me go ahead and just add that up first. So in the denominator, I get 24. And when I add up all these in the top, I get 114. So I've got 114 over 24. And then dividing that out, I get 4.75. So this will be my mean. Okay. And then the last thing I'll do is go ahead and find the median. The median is going to be in the middle. Okay. And again, with this frequency distribution table, you have to take into consideration the frequency. So the middle is not just going to be, between 4 and 5, because I have a bunch of these. So like I said, and I'm not suggesting that you write them all out, but if I were to write these out, I've got 1 1, and then I've got 3 2s, and I have 2 3s, and then I've got 6 4s, and so forth. So I got to figure out where the middle is. Like I said, I remember I have a total of 24 of these. So if I were to list out all 24, where's the middle? So the median is going to occur. So I've got 24 plus 1 over 2. So 25 over 1, I get, 12.5. So the median is the average of the 12th and 13th items. Okay, so now I got to figure out where that occurs. So like I said, after I list all the ones, I have 1 item listed. Then I add the 3 2s. So that's going to give me a total of 4 items listed. And then I put down the 2 more 3s. So now I've got, because I had 4, now I got 2 more, that's 6. Then I list out all the 4s. So I had 6 items plus the 6 4s. It brings me up to 12. And then I start listing, the 3 5s. So 13th, 14th, and 15th items. So if I need the average of the 12th and the 13th, it's going to be a 4 and a 5. So the median is going to be 4 plus 5 over 2, so 4.5. And that'll be the median for this frequency distribution.